If the two bubbles, if they are falling in air, radius A, they're having a radius B, V1, V2. They'll coalesce, they'll form a bigger bubble. What means terminal velocity? My expression for terminal velocity. So drops, these are drops here. And this is a bigger drop. So the two drops coalesce to form bigger drop. Okay, now he's asking now. What will be the new terminal velocity of this one? Any formula for tell me what you should do. The overall the density will be same, no? If the water drop, it will be a water drop only will form two water drops. If they combine, will become bigger water drop. So therefore, the mass will be same. M1 plus M2 is equal to M. What is M1? Rho 4 by 3 pi EQ. 4 by 3 rho 4 by 3 pi BQ. Rho 4 by 3 pi RQ. So what is R cube is equal to EQ plus BQ. And how terminal velocity and the radius of the bubble are related? Anybody? Any formula? Can you suggest? Density of air, if you want to take, you can take density of air. So shall I say it is directly proportional to what? Directly proportional to radius, no? Square of radius. So what shall we do now? So this will be radius of the bigger drop. No? This is a bigger drop. Let's do one thing. So as it is proportional, so shall we write this is R cube. R cube is there. So R is proportional to V to power of 1 by 2. A cube is there, no? A I should replace 3 by 2. Okay, this is all. So therefore, this will be V1 cube plus V2 cube. So there's an expression, or let's just leave it here. I think already this previous exam they came accidentally, but it should be in this one. So this will be the speed of the new bubble. So only thing is what happened, you should take help of the Stokes law here. Okay, agree this. So these are some types of questions can be asked here. So you just do revise all the things. So these problems you try to work out some based on viscosity. These are